Hey, how's it going, Vino?
Hi, Adam. I'm very happy to be here and
Yes.
very excited, actually.
Awesome. Rock and roll. Well, look, as I said, yeah, really grateful for you stepping up and saving the show tonight. So, yeah, ready when you are. If you want to jump onto your share screen there, and we can start the show or your presentation, I should say.
Can you see my screen now?
Yes, we can. It's just loading that presentation mode there. I'm sure we'll. Very good. Yeah, perfect. Influencer AI. Know thy
Yes.
followers. Ready when you are.
Okay, thank you, Adam. Thank you for that introduction. And good evening, everyone. It's a lovely sunny evening. And so thank you for being here inside, ready to listen to us. I feel that our previous presenter, Preeti, gave a really nice segue into what I want to talk today about. So, this is a model that I did when I was trying to move from academics into the industry. So this project was done as part of a program called Insight. And I would give a little bit of introduction to the project, and then what I did, a quick overview of what I did in Tangerine as well in this presentation. So feel free to interrupt me or put in your questions in the chat. I would be happy to answer it anytime. So a little bit about me. So I'm Vinothini, Vino. So currently, I'm a data science manager with the global wealth management team in Scotiabank. I've been part of pricing analytics team of Tangerine, and before that is Insight program, which I just talked about. My background is essentially in astronomy and astrophysics, where I was working on images were like what you see on the right. So I put this image here because it is a very inspiring image. Once you understand what's here in this image, and how machine learning methods can help us unravel what's the information that is provided in this image. So in this image, what you see here on the right, the sun is on the far right. You don't see the sun actually, but you see the external atmosphere of the sun. And this white blob in the middle going across in a crossway is the Milky Way galaxy. And the bright object right in the middle of the Milky Way galaxy you see is the Jupiter, planet Jupiter. And my project was actually not to look at any of these things, but to look at all these teeny tiny dots at the back and track them and do a signal processing on that. And I was able to achieve that along with my team using machine learning models. Which is part of my PhD thesis. So, this image always inspires me that anything is possible with the right tools in hand and the right motivation to do it. So going forward, so this is a project that I did for my insight. So the project is Influencer AI. So I'm sure in the last 2 years, many of us are much more aware of who is an influencer. So here is a quick introduction to who is an influencer. So they are a peer-to-peer marketing. And this is done to social media of different types. So here I have an example of Cristiano's Instagram page, which had at that point in time, about a couple of years back, about 17 million followers, and some of his posts have more than 6 million interactions. So the problem that the company that I was consulting with was trying to solve is how can we help these influencers manage these pages. So to give you an idea as to the market share, I know Preeti talked about ROI as being an important factor for us to have a successful ML model. That is very true when you look at the markets here. So the ROI on the influencer media marketing is fivefold. So for every dollar that you spend, you're on average you are going to get a return of about $5 back. And how does this usually happens is that most of them come from the audience engaging with the post, but some of them do come from the content and the views as well. And the marketing prediction is that in the next 12 months, this market is expected to grow by more than 63%, which is a huge, huge growth if you consider uh, the marketing portfolios of different companies, maybe small or large. So it is a very important theme. So what is the project all about is to identify the intent of these fan messages that are being posted as comments, as interactions with these influencer posts. And the my client wanted to classify the intent as one of the followings here, and thereby help the influencer and their team identify the disruptive comments based on these classifications, as well as have out some ready-made chatbot like answers to comments like the saying, for example, thank you, or how can I help you, that sort of thing. So that is the vision and mission of this project. So the methodology that was followed to achieve that end was twofold. So one is the back end, where you see on the left, which is done mainly with the Colab, Google's Colab notebooks, and the front end, which is also done with the Google infrastructure using Flask. So the first thing we did was we take these comments, which are given to us as a sample, and we strip down the commas, do some pre-processing on them, and then I apply an algorithm called bidirectional LSTM. The results of this model is stored, and then you have the front end where you have a web app where you can go and type a comment, and it would be able to give you the intent of that comment as well. So what I'm presenting here is just an MVP, and it's been implemented currently by the company, by my client. So to give you a little bit more information as to the data that we have, so the sample that was shared with me was about 1,200 comments, which had, as you can see here, the comment and a label, which is the intent in this case. For example, iced coffee is the best is a suggestion. And then the reply that we want the influencer to reply back is agreed. But the fun part begins when you see that these are social media posts, which means there's going to be a lot of slangs involved, a lot of emojis, which you have to understand and interpret as part of the modeling. So here, for the second line is such an example. So OMGs, you have hearts, and then the answer has to, or the reply has to take these emojis and slangs into account when suggesting replies as well. So that is the problem statement. So when we looked at the labels, we found that there is a huge imbalance in the data set. As you can see, most of the comments are appreciation, which is expected. But then there was also comments which are like sarcasm, which are comments you have to deal with very carefully. And when you look at the polarity, what I mean by polarity in this case is whether the comments are positive or negative. You find that there are some very extreme negative comments as well. So -1 on in the plot on the right indicates comments that are extremely negative, and there are some comments like that as well. So it is important that the model distinguishes between these comments when they make suggestions as to what their intent is, and also going forward and suggesting a reply to it. So what's the analysis that we did was standard NLP processing, natural language pre-processing pipelines, which essentially is removing stop words like of and for, and also removing punctuation marks. And also one other pre-processing step that we usually do in NLPs are getting to the root of the word. So for example, here, if I take reduced, the root word is reduced. So we go back to the root word so as to have a better understanding of the data. So once we do such pre-processing on the data set, we undersample some of the classes like appreciation, if you go back here, which has the maximum number of comments, and oversample some of the classes which like request and greetings, which do not have much samples there. Once we do that, we also combine some of the classes together because this is an MVP, and we reduce the number of classes from 8 to about 3. and then we apply the algorithm on that. So this sort of pipeline is pretty standard when when you're dealing with an NLP based problem. The reason for using this particular algorithm is very interesting. So, as the name suggests, so what it does is bidirectional. So, the algorithm is going to look in both forward direction in your sentence as well as the backward direction. And what the LSTM does is what stands for in the first place is long short term memory. So, the algorithm looks at a word. It looks, in this case, because it's bidirectional, it looks at the previous word and the next word and tries to see the relationship between them and tries to understand the relationship between them and then classify them. So we have to see both the previous word and the next word because we are trying to understand the intent of the sentence as a whole, not just trying to find an answer. So some of these intents you need to look into a longer sentence group because, for example, if you're trying to understand sarcasm and you're trying to develop a model to understand sarcasm, you cannot do that by just looking at what's the next word is. You have to look into the entire sentence or the entire comment. So for those purposes only, we tried using the bidirectional LSTM, and this was more successful than even the basic language models like BERT. So at the end of the day, once the model is developed, this is some metrics that we had from the training data set. So from a highly imbalanced data, we were able to make it semi-balanced, I would say, not a balanced data set still. But a semi-balanced with only 3 classes here that we deal with. And the ROC curve, which tells us the receiver operator characteristics of the curve. So the way to interpret an ROC curve is to have your area under the curve more than half of the diagonals. So anything on the far left top, if your data is able to identify the ratio between the false positive and the true positive on the far left, is a good model. So here I have various metrics for either a single label or a combination of labels as well. And you see that most of them are on the far left, which tells me that the model is behaving the way we want it to behave. In terms of results, you have a model accuracy of 66% and the validation accuracy of 62%. And to give you an idea of what it translates into for the business is, say, for example, the comment is T is the best. The model is suggesting the model is outputting, I would say, that it's a suggestion with a confidence interval of 68% and an appreciation for 27 and a question for 4, which is a good thing because T is the best is actually a suggestion and nothing else. Another example that came up from the model results is, say, for example, the comment is so good, LOL. So here you also have the slang LOL, and the model has to understand that. And it is able to pick up that nuance in the comment and able to say that this is most likely 89% likely an appreciation rather than a question or a suggestion. So we understand that the model is performing good. So at this point, we handed the model over to the client for further development because this was a consulting project. And I would say if I were to continue further, these are some of the conclusions that we drew and suggested to the client to take it further as well. The demo is currently not active, but it's a static page right now. But I think Adam might share this deck and you can have a look at the page later on. Next, I would like to give you a quick work outline of a similar NLP project that I undertook as part of the pricing analytics team in Tangerine. So here also the business problem is getting information from voice-based calls. So we had people call into the call center. We have those calls recorded. What is the how can we help the business make better use of these recordings? So, as Preeti was mentioning, this was an unsold ML use case, because we took up these as a product team, and we decided, okay, we have this data set. What can we do with it? How can we help the business make better use of this data set? So this is a pipeline that we developed, and it helped the business in identifying their pain points, and we were also able to provide solutions and address those pain points for them. And the end product of this use case was that we were able to have a monthly dashboard, which was developed using Google Data Studio, that the business was able to use and understand their and get a brief bigger picture of the call center calls that are coming into their call center, and how they can make better use of the data that they have. So, as I said, first step is converting from voice to text, and then you go through standard NLP pre-processing. And then comes the interesting part, because this is a conversation between the customer who calls in and the agent. We were able to separate out into the customer part of the conversation, the agent part of the conversation, as well as the combined part of the conversation. And for these three different sets, we did topic modeling, figuring out what is the main topic of conversation. Are they talking about credit cards? Are they talking about savings accounts? Or are they talking about a complaint? And then figure out how the sentimentality of these calls are in general, as well as how it changes through the lifetime of the call itself. Whether they start out, the customer calls up angry, but then end up being satisfied with their resolution that is being provided to the client. And also, we were able to give a call summary. And all of this information ended up being presented to Google Data Studio dashboard, which the business was able to use extensively and gain further insight into what's happening with these calls, and how they can better the client service that we provide to the clients as well. So, with these in mind, I would like to thank you all for your time and attention, and I welcome any questions or comments further. I pass it on to you, Adam.
There. So yeah, look, thanks so much for that. I'll certainly open it up to some questions. We do have one in the chat, but also ask our audience to please put some emojis in the chat to say thanks to Vino. Cool. So we did have a question. Let's jump in. Marwa has actually commented there. She has said, "How do you define the intent? Did you go through each comment to
That's a very
it?"
good question, and one of the most time-consuming part of a project, getting your data set ready for your ML model. So the intents were defined by the business. They wanted to classify into the 8 intent categories that I showed you. And they gave a small sample set which was already labeled with those intents. So our problem was much reduced in that sense, that the business knew what they wanted and how which comment should become which intent. But on a general use case, you would either have to manually classify them, or run through clustering methods, where you can cluster the data set to get the labels, and then label it, and then use that as a training data set for your classification model. So those are ways you can handle it if you're facing such a problem in the future.
Yeah, I think it's a great question there, Mawar, and I think that's a pretty spot on response there as well. So thanks so much for that. Look, we'll open it up for another little bit if we do have questions. Marwa asked, "My question is whether you had a thought about feasibility to make it a real-time analysis."
Indeed, I did. So that's why we have the front end developed, so that it can be connected as an API into the whoever the influencer is, and they can pull out the model information and type in. So the moment you get the chat or the comments, and they would be able to get the intent as well as have a pop-up reply as well. So that was the suggestion to the client that we gave as part of this project, to take this model from MVP into a production based.
Very good. Thank you so much for that. Yeah.